Welcome back. In this video, we'll take a look at how to use pickle for storing pybamm solution. We'll start with creating a solution with LFP chemistry discharge at 1C, then use pickle to store the solution. Then in a second notebook, we'll create a solution 2 where we'll solve for NMC, discharge at 1C, then use pickle to load the solution 1 and override the results. And then finally, look at the results being updated from NMC to LFP. So on the left, you can see in the given folder, I have two notebooks, and pickle is basically a library which can help you store solutions in general, which can be reused across notebooks. So let's begin. I'm reusing a code from previous video. If you have not watched it, please do. I won't go into the details of how this is set up, but basically we are extracting a database Prada 2013, and in the next one we'll import Chen 2020, which represents LFP and NMC chemistry respectively. And this code represents basically starting off with calling pybamm.lithium-ion.dfn, storing it in dfn variable, then extracting pybamm.ParameterValues of Prada 2013, storing it in the variable param, then calling pybamm.Simulation, passing on dfn and the parameter values of Prada as input, storing it back to simulation, SIM, then doing sim.solve. Without experiment, we need to define time. So it goes from 0 to 3600. We're storing it back in sol, and then finally plotting the result. So when we do that, we can clearly see the voltage plot at 1C, which is 2.3 amps, is looking similar to what we expect for an LFP graphite combination with a flat voltage and the voltage value ranging between 3.6 and 2 volts. Now, if you have not installed pickle, you can just do pip install pickle before importing it, and then use this code. So to break it down, we are importing pickle. Then this is a syntax to basically create a solution file. With open, solution.pkl file is the file where the solution would be stored. And we need write permissions, so we are calling wb write binary, and then defining a variable as f. So after opening this file with write permissions, what we want to do, we want to dump the solution of this notebook. So pickle.dump, then sol and f. It takes inputs as object and the file name. So once we do that, you can see a file being created here, solution.pkl. Now let's jump onto the second notebook and see how we can import it. We'll again copy this code, go to the second notebook, change Prada to Chen 2020, and rename the solution to sol2 to avoid confusion. So you can now see the voltage curve resemble more of an NMC graphite combination ranging from 4.2 volts to 2.5. Next, we will copy this part and make slight modification to it. So import pickle with open solution.pkl with read permission now instead of write binary. Read binary sf, and now we don't want to dump the solution, rather we want to load the solution. So we'll call solution2 is equals to pickle dot load, and then pass on the file name. So hit enter and see the magic. Now we'll do sol2.plot again, and there we go. So you can now see the voltage curve is no longer representative of NMC, which was called here with Chen 2020. Rather, it's updated to LFP as we overridden the solution from 4A into 4B. So this is how you can use Pickle to dump and load solution across notebooks, helping you make complex code with adding ability to break it down into smaller chunks for effective management and maintenance. Hope this was helpful. See you in the next one.